Alright everybody, we're going to do 13.1.3 measures of center and spread. I'm going to use Desmos a little bit here. And what I'm going to do to spend my time is there's a little calculator or keyboard on Desmos. And there's a functions thing. I'll use that almost the entirety of the time. Alright, so let's jump into it. Let's talk about what mean is. Mean is the average. So what the general understanding of what an average is you add all your data values up, add them all up, and then you divide by however many total data values were. The median is the middle situation. So whatever is in the middle is your median. Your range is your biggest, your smallest. Um, and then your standard deviation is the average distance from the mean. And let's get into it. So Jamie McAllister is a wonderful rebounder for our high school basketball team, probably the Pickerington High School Central Tigers or the Pickerington High School North Panthers, I'm sure. Of her final 10 games, here are her rebound totals for each game. So they give us a list of numbers. From the collected data, what is the mean of the rebound? So basically I need to do 8 plus 12 plus 8 plus 11 plus 15 plus 6 plus 9 plus 8 plus 10 plus 13. And then so add all those numbers up and then divide it by 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10, right? So 10 games. Now, what I'm actually going to do, because maybe I'm lazy, I'm going to go over here. I have my keyboard. I'm going to go to functions. I'm going to go to stats. And I'm going to go to mean. And all I'm going to do is I'm going to type in those values. And what is her average? Her average is 10. Right? Her mean is 10. So mean and average is the same thing. So I'll probably just use it interchangeably because I'm not thinking about it. But all I did was I just kind of plugged the information in. We could calculate this ourselves, right? But we have access to the resources. We're just using a calculator anyways. Might as well just save ourselves the extra step, save time. All right, so now we want to know what the median is. All right, so what we should do is we should order the data set from smallest to biggest, and then we start cutting to find the median. Or I can just go here, median. Actually, I'm going to make it smarter since I know what it's called. I already have the data filled in here. There's a median. So the median is going to be 9.5. I just changed the function name. Now what is the range? Now the range is I need to find the smallest. So 6 is my smallest. I need to find my biggest. 15. So I have my biggest and my smallest. So I do 15 minus 6, and I get 9. All right, so I find the biggest number, I find the smallest number, subtract them, and that number is my range. I don't even know if there's a range option, and yeah, I don't think you need to anyways. So find the biggest, find the smallest, subtract, there's your range. Complete the table to find the standard deviation. Okay, so again, I'm back into my keyboard on Desmos stats, and there's standard deviation. All right, so standard deviation is STDEV. Since I already have my data filled in, I'm going to change this median and just change my function. So, and then 2.75 is my standard deviation. All right, so we could do it by hand, but why? I guess why? You'll never have to do it in the real world, so why? Right, and this is it doing it by hand, which it's an easily calculable thing. You guys are capable of doing it, but I mean, come on, it don't matter. When a small outlier gets added to a sample, so when a small outlier, right? So when small and an outlier, the mean will get smaller. When a small outlier is added to a sample, the range gets larger, right? So if I did 15 minus 6 and I got 9, if I did 15 minus 5, I got 10, so my range would get bigger. When a small outlier is added to a sample, the standard deviation gets larger. So when a small outlier is added to a sample, the standard deviation gets larger. So what is the better measure of center for these data and why? All right, so measure of center would be mean, median. So we're gonna decide. Well, if I'm looking, I have 18, 19, 20, 20, 23, 26, and 260. All right, so we have a number that does not fit. That's an outlier. 260 doesn't match. Now, if we do the mean, right? If we do the mean, and I type these values in, I get a mean of 55. All right, so I get a mean of 55. Let's do median. I get a median of 20. All right, so when I do the mean, I did the average, I get a 55. When I do a median, I get 20. If I look at this data, which one would you believe is more accurate, 20 or 55? Well, 20 is obviously. So whenever we have a large outlier like that, it's always going to be median. Median is going to be the better option, right? Because it's not as greatly impacted by an outlier as the mean is. A mean is an average, or a mean is greatly impacted by an outlier. So anytime we have an outlier, use median. Okay, we got mean weights and deviations for 2 samples of puppies. Breed A has the higher average weight, right? So breed A has 42 pounds. Breed B has 30 pounds. All right, so, oh, sorry, and breed B has weights that are more spread out, right? So obviously we can easily tell that breed A has a higher average weight. Like, that's obvious. Now, are more spread out. Remember that our standard deviation is the average distance from the mean. So the average distance from the mean. So it is discussing spread. So if we have a 4.8, that would make it more spread out, meaning the data is further away. So that's breed B as weights that are more spread out. If a dog weighs 12 pounds and is added to the sample for breed A, right? So we just added a small outlier. Maybe it's not an outlier, but we're adding a small weight. The new standard deviation is likely to be greater than 2.4, right? And that goes back to when we add a small outlier, the standard deviation gets larger. We added a small outlier, so it's got to be greater than.